right, Math 12A, I just want to review a little bit from the last half of chapter 5. Someone said if I could just do ones with two absolute value signs where you have to like make one positive, make one negative. Before I do that, I do want to make a point that if you have something like root x plus 2 equals 9, let's say that was the question, if there is an equals sign, then your answer should be x equals something. X equals 7, x equals 3.2, x equals, I don't know, whatever it is, but x equals something. But if I have this same question and it says root x plus 2 is greater than 9, you should not have an answer that x is equal to 3.2. It's got to be x is greater than something or x is less than something. Whether you write it that way or whether you write it on a number line, it doesn't matter. But it should be a range of answers, not just x is equal to something. If there's a greater than or less than sign in the question, there should be a greater than or less than sign in the answer. And I remember when I was marking some of these, some of you did not do that, and it really hurt you. So, going back, the absolute value section was section 5.5. And so I'm going to deal with, I'll deal with an equals one, and I will deal with a greater than or less than one, and you can see the difference, okay? So I am randomly picking these, okay? I am randomly picking these. This is not a setup in any way, shape, or form. I am going to just randomly pick one, and I am going to pick the absolute value of m plus 6 minus, and I'm actually doing a minus on purpose, so it's random, but it's not that random, is equal to 2. Okay? When there are two absolute value signs, I still think of this in terms of a number line, but my answer is still going to be x is equal to. The only reason I think of a number line at all for one that has an equal sign in it is I need to think about what do I make positive and what do I make negative. So the thing that would make this bracket, this absolute value sign 0 would be negative 6. And the thing that would make this one 0 would be negative 4. My answer is still going to be x is equal to something, all right? Now, again, I picked this because there's a minus here, and that threw probably 80 to 90% of you off on a test. You did it wrong on a test. So that's why I picked one that has a negative here, because that's actually important, because you screwed up your signs big time when there was a minus there. So what we need to think about is if your value of m is anything less than negative 6, will this bracket be positive or negative? And will this bracket be positive or negative? So if I pick something less than negative 6, say negative 10, negative 10 plus 6 would be negative 4. So this actually works out to be negative, okay? This minus is here, so I'm putting it here. Now, if I put negative 10 in here, negative 10 plus 4 is actually negative 6. So that works out to be negative m plus 4 is equal to 2. Now the thing is, I have a negative and a negative, which is going to work out to be a plus. Some of you did not write out very much work when you did this, and it hurt you because you screwed up the signs. When I followed it through, you ended up messing up the signs because you weren't actually able to do it in your head as well as you had wanted to. So this, if I solve this, works out to be negative m minus 6. This actually is a plus, so plus m plus 4 equals 2. So negative m plus m is actually gone. Negative 6 plus 4 is negative 2 is equal to 2, which actually isn't true at all. So that means that section, there's no answer in that section that actually works. I'm going to cheat and look at the answer because I did steal this. If you're looking for what in the world is she doing, she's doing page 296, number 45. And page 296. Number 45. Okay. So, nothing in that section works. So now I'm going to say, what about numbers that are between negative 6 and negative 4? So negative 5, what will that do? Negative 5 plus 6 would be a positive 1. So it's going to be m plus 6. The minus is there, so I'm going to put it there. And if I do negative 5 plus 4, that is a positive m plus 4 is equal to 2. Now this time I have a negative and a positive together, meaning that is minus. So I have m plus 6 minus m and minus 4 equals 2. So m take away m is gone, and I have 6 take away 4. That is 2 is equal to 2. That actually works. That actually works. Hold on. Okay, so it shouldn't work. So what did I do wrong? Because it says it shouldn't work. So let me do that again. Negative 5. Negative 5 plus 6 would be positive. And negative 5, oh, because I'm wrong. Because I'm wrong, right? Did you see that? Were you yelling at me? Let me think this through again. Okay, so if I choose negative 5 plus 4 is negative 1. So the minus is here, and the answer works out to be negative. And so this is actually a plus. So I have m plus 6 plus m plus 4 equals 2. So I have 2m plus 10 equals 2. So 2m is equal to 2 minus 10, which is negative 8. Divide both sides by 2, and I have m is negative 4. Okay, so check that. Check that. Put that back up in here. Negative 4 plus 6 is negative 2. The absolute value is 2. Negative 4 plus 4 is 0. So 2 minus 0 equals 2. Hey, that works. So m is negative 4 works. So now let's go to above. Okay, let's go to above. So if I pick a number bigger than negative 4, 0. 0 plus 6 is positive. So it would be a positive m plus 6 minus, because there's a minus there. Now 0 plus 4 is going to be positive 4. So here I have m minus 4, or sorry, plus 4 equals 2. Here's the place where I have a negative and a positive together to make a minus. So I have m plus 6 minus m minus 4 equals 2. So m take away m, and 6 take away 4 is 2 is equal to 2. Here is one of the only places where my answer is actually going to have a greater than or less than sign in it, even though there's an equal sign. So when you have two absolute value signs and there's an equals here, it is one of the only times when it is possible that you could end up with a greater than or less than sign in your answer, because this worked out, right? This generic thing, which represents anything above -4, works. So basically, if I put any number in there that's bigger than -4, it's going to equal 2. Let me test it. 0 plus 6 is 6. 0 plus 4 is 4. So 6 take away 4 is 2. Let's try 10. 10 plus 6 is 16. 10 plus 4 is 14. Hey, look, 16 take away 14 is 2. Any number that I pick, if it is -4, because we already established if it's equal to -4, it works, that any answer that is -4 or bigger will actually give us an answer of 2. So that is actually a strange one. So of course I picked the weird one. So if I were to graph that, I could do it on a number line, or I could give my answer this way. M, it has to be bigger than or equal to -4. So break it up, figure out what would be positive, what would be negative, pay attention to your signs. Again, if there was a minus here, that really messed up a few of you, quite a few of you, in fact, on the test. I remember that because I remember thinking, wow, I thought I emphasized that enough, but I guess I didn't. So the same thing would be true for a greater than or less than when you would do exactly the same process. All right, you would do exactly the same process. So again, I'm just picking x minus 5, the absolute, hey rules, plus the absolute of x minus 3, this time I'm doing a plus, is less than 9. So again, 5 would make that bracket 0. 3 would make that bracket 0. So if I pick a number less than 3, like 0, 0 take away 5 would be negative x minus 5 plus 0 take away 3 would be negative, so negative x minus 3. So a plus and a minus make a minus is less than 9. So negative x plus 5. Be careful with that. That negative has to be distributed to that whole bracket. I have a hair, there we go. It has to be distributed in the whole bracket. A bunch of people, again, it was not just 1 or 2, it was several people, would tell me that was negative x minus 5. But no, the negative's on the x and on the negative 5, making it a plus. So negative x plus 3 is less than 9. So that's negative 2x, and 5 plus 3 is plus 8 is less than 9. So we're going to move this over here. Negative 2x is less than 1. 9 take away 8. I'm going to divide by negative 2. I'm going to divide by negative 2. Don't forget, if you divide by a negative, flip your sign. I'm glad that happened. So x is greater than negative 1/2. Now remember, we were looking at this section. We were looking at less than negative 3. So at -1/2, x is greater than, but I can't make a statement beyond that 3 because I was only testing for numbers below 3. So I'm going to just stop my line there. It might continue, but it might not. So that's what I need to find out. So between 3 and 5, 4. 4 take away 5 would be negative x minus 5 plus 4 take away 3 would be positive x minus 3 is less than 9. So negative x plus 5 plus x minus 3 is less than 9. So my x's are actually gone. And I have 5 take away 3. 2 is smaller than 9, which is actually a true statement. That is true. And that was for this section in here. That was for numbers in between the 3 and the 5. It's true. So I'm going to keep going. I'm going to keep coloring that line. And then for numbers bigger than 5, so 6. 6 take away 5 is a positive, and plus 6 take away 3 also a positive. And so I have x minus 5 plus x minus 3 is less than 9. So 2x minus 8 is less than 9. So 2x is less than 17. So x is less than 17 over 2. Or if you like decimals better, 8.5. So here's 8.5. X is less than, and it's going to join up. So x is greater than -1/2, but less than 8.5. So again, you have your answer in number line form, but you could write it x is greater than -1/2, but less than 17 over 2, or 8.5. It's up to you, all right? So I'm going to leave that there. I'm just double checking. Yep. I'm going to leave that there because someone said, can you go over absolute value signs when there's like 2 of them and you have to make one positive, one negative? So I did that. If there's more you want me to go over, let me know and I will hopefully make up a quick video on that. Okay? Talk to you again soon. Maybe, or maybe not. We'll see.